Why are scientists surprised about the asteroid sample they've retrieved from the OSIRIS-REx probe? NASA's OSIRIS-REx mission has achieved a significant milestone in space exploration.
For all of NASA's many missions over the years, OSIRIS-REx lives in an extremely rare category. It not only ventured out into space with cameras and sensors, but it's bringing a physical sample of the ancient solar system back to Earth for detailed analysis. Mission planners selected a small asteroid called Bennu as their destination.
After a journey spanning billions of kilometers in 7 years, the mission has successfully returned with a sample from the asteroid Bennu. This sample, encased in a small black capsule, blazed through our atmosphere before making its landing in the Utah desert. The primary objective of this mission was to collect and return a sample from Bennu, a near-Earth carbon-rich asteroid. The spacecraft orbited Bennu for 2.5 years, meticulously mapping its surface and gathering vital data about its properties. The OSIRIS-REx mission's success is monumental. Not only did the spacecraft travel to Bennu and back, but it also had to match Bennu's speed, identify a safe landing spot, collect the sample, and then return to Earth. Why is Bennu even important enough to spend 7 years and billions of dollars on? Because asteroids like these are the remnants from the early solar system. They hold clues about its formation and the origins of life.
These are literally the time capsules of the early solar system, with those bits and fragments we can never get here, so we go and bring them home to connect ourselves to the place we live, our solar system.
While telescopes on Earth can provide some information about asteroids, direct samples are much more valuable. Most asteroid samples on Earth come from meteorites. However, these meteorites have undergone changes while passing through our atmosphere, making them less pristine than samples collected in space. Upon its return, the capsule was transported to NASA's Johnson Space Center in Houston. In a specially designed super clean curation facility, scientists got their first look at the dust grains from Bennu. The capsule had a pleasant surprise for the scientist, as the amount of sample gathered from the asteroid exceeded the expectation. This mission was a once-in-a-decade opportunity to obtain such a sample, and the results were more than sufficient. The dark, fine-grained material on the inside of the container's lid could reveal insights about the asteroid before the primary sample is analyzed. The spacecraft's sampling mechanism, known as the touch-and-go sample acquisition mechanism, was used to collect the sample. During the collection process, the spacecraft briefly touched the asteroid's surface and used a burst of gas to funnel rocks into the tag sam. Some of these rocks were larger than expected, causing a slight leakage of the sample into space. Despite this, the mission is believed to have returned with around 250 grams of specimens, making it the largest asteroid sample ever collected. The next steps involve a detailed analysis of the sample. Scientists will carefully open the tag sam to hopefully find larger rock fragments. This process will provide insights into the composition of Bennu, and by extension, the early solar system. Furthermore, about 70% of the sample will be preserved for future research, allowing scientists equipped with advanced technologies to study it in the coming decades.
That the work we do here will be available for scientists perhaps watching now, perhaps not yet born. They can make choices and come up with their own hypotheses, their own ideas, their own new techniques to look at the sample in new and exciting ways.
The OSIRIS-REx mission has opened a new chapter in our understanding of the universe. The samples from Bennu will not only enhance our knowledge of asteroids, but also provide insights into the origins of life and the early solar system.